Humanoid robot grabs student. Humanoid robot unexpectedly hugs student at China University event, triggering AI safety debate. A surprising incident at a university event in China has gone viral after a humanoid robot unexpectedly turned and embraced a female student during a live dance performance, raising fresh concerns about artificial intelligence safety and human robot interaction. Now it's time to go in detail and uncover the full story in today's AI podcast.
Imagine you are sitting in the audience at a major university event. The music swells, the lights drop, and you are watching this beautifully choreographed dance routine.
Right, with human dancers moving with, perfect practiced grace.
Exactly. And right there among them is a humanoid robot, hitting all its marks. I mean, you expect a certain type of precision, right?
Yeah, absolutely. There is this implicit trust in that space. We just assume an absolute binary control over the hardware.
Like, it either executes the routine perfectly or it just stops.
Exactly. You figure it's a machine, it follows a script, so the boundaries between the performers and the metal are totally predictable.
But then, right in the middle of this performance, that script gets thrown completely out the window.
Oh, totally out the window.
The titanium dancer just stops following its code. It turns away from its programmed path, walks over to one of the female student dancers, and literally wraps its mechanical arms around her in a hug.
Which is just wild to think about.
Right. Suddenly, that feeling of safe, predictable precision is just gone. So welcome to the deep dive. Today, we are breaking down this massive viral incident that recently unfolded at the opening ceremony of a sports meet at Shan University.
Yeah, in Shaanxi province. And we really need to get into this because what looks like a funny internet glitch is actually exposing a massive, terrifying blind spot in how we engineer our future.
We're going to cut through all the wild internet speculation today and find the real aha moments about human-robot interaction.
It's honestly a diagnostic nightmare, but this specific incident beautifully, and somewhat terrifyingly, shatters the illusion that a machine's physical shell and its underlying software are perfectly aligned.
Yeah, we are watching the collision of cutting-edge, crowd-pleasing entertainment with the very real, very unpredictable physics of human safety.
Which was completely on display in the immediate aftermath on that stage.
Oh, it was chaotic. Like, staff members had to physically rush out under the lights, grab this machine, and pry it off the student.
Thank goodness she was entirely uninjured.
Right. Though she understandably declined to speak to the media later. But, I mean, you can imagine the footage. Someone catches this on their phone, and it just explodes across Chinese social media platforms almost instantly.
Of course it did. The visual of a cold machine performing such an intimate human gesture is incredibly potent.
Okay, so let's unpack this, because the debates online were wild.
Oh, totally. People were absolutely convinced it was a secret PR stunt orchestrated by the university.
Yeah, or others swore it must have been remotely controlled, like by some bored engineering student backstage playing a prank.
But the most tantalizing theory, the one that absolutely caught fire in the comment sections, was that this robot had somehow developed independent awareness.
Yes, that it was exhibiting emotional behavior. And it really shows how desperately we human beings are wired to seek consciousness in machines.
We really are. We are biologically programmed to anthropomorphize.
Because it was a hug, right? It's this uniquely, deeply human gesture of affection. So our brains see that specific motion and we instantly leap to sentience rather than, a software glitch.
Exactly. When an object has a head, two arms, and mimics our movement, we just project human intent onto cold hardware.
I mean, think about it. If that exact same robot had suffered a glitch and violently swung its arm, smashing into a speaker stack or something.
Right, or knocking over a lighting rig.
Yeah. Nobody on social media would be arguing that the robot was angry at the sound system.
No, they would just assume the motor broke or the code crashed.
Exactly. But because the mechanical failure happened to mimic a gesture of human intimacy, we totally bypass our logical understanding of how a machine operates.
Which forced the university to come out publicly and vehemently deny that this was a planned stunt.
Right, they had to shut that down fast.
They stated very clearly that, based on their understanding of the hardware, the robot simply malfunctioned. It unexpectedly turned, moved toward the student, and required physical intervention.
It really highlights this dangerous gap between how a machine looks, its friendly humanoid shell, and how it actually operates underneath.
Because underneath that shell, it is literally just code, wires, and heavy motors.
So, since we can safely rule out the idea that this robot suddenly developed a sentient crush on a college dancer.
Right. No robot crushes today.
Yeah, we have to look at the mechanical reality. If it wasn't a sudden spark of artificial emotion, what actually caused a heavily programmed machine to abandon its coordinates and just wander into human space?
Well, the answer requires looking at the environment, not just the internal code of the robot itself.
Okay, so break that down for us.
So the robot was supplied by a robotics company founded by university alumni. And after the dust settled, the university naturally demanded a full explanation.
As you would.
Right. And the company's official diagnostic report confirmed it wasn't staged. Crucially, they also confirmed it wasn't a foundational flaw in the robot's internal dance programming.
Wait, really? So the code was fine?
The code was fine. The culprit was actually flying right above the performers' heads.
The camera drones.
Exactly, the drones. During this opening ceremony, there were multiple drones flying simultaneously to film the event.
And those drones operate using wireless signals, right?
Yeah, they flooded the airspace. They caused severe signal interference. This invisible web of radio frequencies basically jammed the robot's control system.
Oh, wow.
It completely disrupted its ability to follow its programmed routine, which led directly to those abnormal movements.
Let's break down how that actually works for anyone listening, because it's not magic. It's basically like trying to stream a 4K movie on your Wi-Fi router while every single person in your apartment building decides to download massive high-definition files at the exact same second.
That is a perfect analogy. The frequencies just get totally crowded.
Right, and on a screen, your movie freezes, the audio drops out, it buffers. But for a robot, the buffering doesn't just mean a frozen pixel.
No, the buffering translates into physical space.
Exactly. It results in a 100-pound piece of metal wandering completely off its script toward a living, breathing human being.
What's fascinating here is that humanoid robots rely on a continuous loop of telemetry data just to stay balanced and execute commands.
So they're constantly talking to their network.
Yeah, constantly pinging their environment, receiving positioning data, communicating with a local server or their internal navigation sensors.
And then the drones come in.
Right. The drones were likely broadcasting high-definition video and receiving flight commands over standard 2.4 or 5.8 gigahertz frequency bands.
Which is the exact same frequency the robot is probably using.
Exactly. So if the robot is operating anywhere near those same channels, its signal-to-noise ratio just plummets. It's essentially a distributed denial-of-service attack, a DDoS attack by accident.
So the robot's processor gets flooded with junk drone signals, and instead of processing its next dance step, it's just trying to parse all this chaotic noise.
Its computational resources are totally overwhelmed. The command to, say, stay within these coordinates gets dropped or corrupted.
Which is crazy to think about.
It really proves that no matter how sophisticated a robot's internal programming is, an external, entirely low-tech disruption in the radio frequency environment can derail the entire system.
So it wasn't an AI failure where the software decided to do something malicious?
Not at all. The machine essentially went blind and deaf, but kept its motors running.
Okay, the Wi-Fi jamming explains the glitch perfectly. But here's where it gets really interesting to me, because that raises a much scarier question.
What's that?
If my laptop loses Wi-Fi, or if its processor gets overwhelmed, it just freezes, the screen locks up. Why didn't this heavy machine just stop moving? Why is the default response to wander off and physically engage a dancer?
This is where we need to look at the analysis from AI expert Gao Huan in the source material.
Right, because he totally dismisses all the self-awareness theories.
Completely. He focuses entirely on the mechanical truth. Motion control errors, execution deviations, positioning failures.
But his core argument kind of shifts the entire conversation, doesn't it?
It does. His critical point is that the most alarming part of the Xi'an University incident wasn't the sudden turn or the glitch itself.
Right.
It was the fact that the robot was still able to physically make contact with the human after the system began failing.
See, I have to push back on Gao's point here, or at least challenge the premise of how these modern bots are built.
How so?
Well, industrial robots in car factories have had automatic shutoffs for decades. They sit in physical cages, and if they sense a millimeter of deviation, or if a human breaks a light curtain, they instantly lock up.
Oh, absolutely they do.
Are you telling me a modern, highly funded humanoid robotics company building machines for public stages just forgot to install a basic failsafe.
Well, it's not that they forgot, it's that free-walking humanoid robots operate on a completely different architectural paradigm than those bolted-down factory arms.
Okay, explain that difference.
The factory robot, like a KUKA arm welding a car frame, operates in a perfectly controlled environment. Its safety mechanism is often just a physical relay. You break the light beam, it cuts the power to the motors instantly.
No software required.
Exactly, no software required. But a humanoid robot on a stage doesn't have a physical cage or a light curtain around it. It has to rely entirely on its own software and sensors to decide if it is safe.
Oh, I see. And if the software is the very thing being corrupted by drone interference,
Yeah.
it can't accurately judge its own safety.
Precisely. To freeze, a robot needs the spatial awareness to realize, wait, my actual physical coordinates do not match my programmed safe zone.
It essentially has to know it is lost.
Right. But giving a robot that level of continuous real-time environmental awareness requires massive onboard computational power.
Which these bots probably don't have.
Most of these lightweight entertainment bots simply don't. They often rely on something called dead reckoning.
A dead reckoning, meaning it just counts the rotations of its own motors to guess where it is on the stage.
Yes, exactly. It says to itself, I moved my leg motors forward for 2 seconds, therefore I am at coordinate X.
Well, that sounds so fragile.
It is. If interference causes even a microsecond delay or a motor turns too far without the sensors catching it, the robot still thinks it's standing in its safe zone.
So it is physically at coordinate Y, but its internal map says it's at coordinate X.
Yes.
It is essentially sleepwalking. It doesn't know it's in the wrong place, so it keeps firing the motors, executing a perfect dance routine just 10 feet to the left of where it should be.
Yeah, it lacks the contextual awareness to stop. It just has momentum.
Wow.
Think about it. When a human dancer forgets a step or loses their balance, they have the biological hardware to instantly process that failure. They adjust their weight to make sure they don't tackle their partner.
Right. Our brains do that automatically.
But a robot, stripped of its sensory data by interference, has no contextual awareness. This highlights the immense danger of treating humanoid robots like ordinary stage props.
Right, because a microphone stand is a prop. A lighting rig is a prop. A humanoid robot is an intelligent, heavy piece of machinery.
Exactly.
The core issue here really is momentum versus intelligence. It's not about malice, it's just about mass and motion.
Yeah, the default state of the robot is execute command, not verify human safety.
Which is terrifying. And that realization really forces us to look beyond this one specific incident in China to explore how we are going to have to adapt our physical spaces entirely.
We absolutely have to. We are entering an era where these machines are becoming a normal part of our daily lives.
So what does this all mean for us?
Well, Gao Huan issued a really stark warning regarding this transition. Robots carry real mechanical risks, and those risks are multiplied exponentially when human performers, or just regular pedestrians, are sharing that space.
Because humans move unpredictably.
And the environment changes unpredictably.
Think about the next time you take your kids to a theme park, or walk through a technology exhibition, or just attend a school event. The presence of humanoid robots is about to skyrocket.
It really is. They're going to be walking the same sidewalks and sharing the same stages as us.
So this incident isn't just about a viral, funny malfunction. It is a massive wake-up call about the safety standards we currently have in place, which, based on our source material, are shockingly primitive.
Yeah, Gao Huan proposed a series of safety protocols that he argues must become the absolute industry standard before these interactions become more commonplace.
Let's go through his list because it is incredibly revealing. First, he recommends full motion script testing before events.
Right. Basically, run the program to make sure the robot actually knows the dance.
But testing in a sterile laboratory environment is entirely different from testing in a dynamic public space.
Which leads to his second and perhaps most vital recommendation, rehearsals in the actual venue.
That makes so much sense.
You just cannot simulate the complex radio frequency soup of a live event in a quiet robotics lab.
Right, because of the environment itself. I mean, if they had rehearsed in the actual stadium, while the drone operators were also rehearsing their camera sweeps.
They would have caught the signal interference immediately.
Exactly. The drone frequencies would have jammed the robot during a dry run instead of during the live performance with people around.
The environment is a variable that fundamentally changes the machine's capability.
Okay, what else is on his list?
His subsequent recommendations are all about containment and physical intervention. He lists maintaining strict, safe distances between robots and people and having robust emergency stop systems.
This goes right back to what we were saying about industrial factory arms. If the robot goes blind, there needs to be a big red button somewhere that immediately cuts the power to the motors.
Yes, because relying on the software to catch its own error is a paradox.
Right. If the software is malfunctioning, it obviously cannot be trusted to execute a shutdown command.
You need a physical interrupt, a hard kill switch.
Yeah.
And this ties into his final points. Having human supervisors nearby at all times and establishing concrete backup contingency plans for when, not if, the machine fails.
When, not if. Reading through Gao's list gave me a very unsettling realization. We look at these robots on social media doing backflips or dancing or serving coffee, and we think of them as friendly, automated companions. Like, I don't know, an iPhone with legs.
Right, they look so approachable.
But this list of safety protocols, kill switches, safe distances, human supervisors, it sounds exactly like the safety protocols you would see on a heavy manufacturing floor.
Oh, totally.
We are treating them like iPhones when we should be treating them like forklifts.
If we connect this to the bigger picture, that is the exact paradigm shift that needs to happen in public perception and engineering standards.
Absolutely.
The excitement over technological innovation, the desire to have a cool, futuristic opening ceremony is currently completely outpacing the development of strong, standardized safety protocols.
Which is pretty alarming.
It is. The fact that the embrace at the university ended harmlessly, with no injuries, was frankly pure luck. The robot just happened to execute a closing motion instead of a striking motion.
And as any structural engineer will tell you, luck is not a safety protocol.
Definitely not.
So to quickly recap the journey we've taken today, what started as a viral video of a robot hugging a dancer at a Chinese university wasn't the dawn of machine sentience.
And it wasn't a clever PR stunt.
No, it was a mechanical failure caused by something as mundane as signal interference from camera drones. The frequencies overwhelmed the robot's telemetry loop, causing it to go blind and wander off its coordinates.
But that seemingly small glitch exposed a massive, glaring lack of physical safety protocols in human-robot interactions.
It showed us that when a machine loses its script, it doesn't always freeze. Sometimes it just keeps moving forward, driven by momentum rather than intelligence.
And that reality leaves us with a rather profound paradox to consider as we move forward into this new era.
Let's hear it.
Engineers and designers are increasingly building these robots to look exactly like us. They are giving them expressive faces, articulated arms, and fluid, human-like movements specifically to make us feel more comfortable around them.
Right.
But does that comforting humanoid design actually make us less safe?
Oh, wow. That is a great question.
Because when a machine looks and moves like a friend, our basic human instincts might cause us to drop our guard. We anthropomorphize the hardware.
We forget what it really is.
Exactly. We might forget that beneath the friendly face and the choreographed dance moves, it completely lacks the biological instinct to protect us. It is still just an unpredictable piece of heavy industrial machinery.
You expect a certain type of precision, right? A titanium dancer following a script. But when the script breaks, you definitely don't want to be the one caught in its path.
Definitely not.
Thank you so much for joining us on this deep dive. We hope this gave you a new lens to view the headlines. And as always, we encourage you to keep questioning the world around you.
Okay, one question for you. Did this humanoid robot really malfunction at the China University event? Or are officials hiding the truth about what caused it to suddenly hug a student during a live performance? Don't forget to comment it. Thanks.